Hi, my name is Caleigh. I am a 20-year-old game development student studying at the University of Applied Sciences in Amsterdam. At the moment, I'm working with a few fellow students on a game called No Control. No Control is a 2D puzzle platformer in which the player starts each level with no controls. By picking up items in the game, the player will unlock the basic game controls as the level progresses. Something I was trying to figure out was the main menu of the game. We weren't exactly sure what would work in the context of our game. I was pondering this for a few hours when inspiration randomly struck. I was sitting in a Discord call with a friend of mine who produces music. He was minding his own business, aimlessly checking the stats of his most recent endeavor when he pulled up the audio spectrum data graphs. I was fascinated by how the graph moved with the beat of the music, and I thought to myself, this is perfect for a main menu animation. And thus began my journey into the unknown world of Unity audiovisuals. The first thing I did was look up some inspiration pictures and videos to try to get an idea of what I wanted to make my system look like and what the possibilities were. There were a lot of really cool examples I found online, such as the ones that you can see right now. All these examples left me feeling inspired and ready to implement an audiovisual system into our project. And thus began my trek to find information on accessing audio spectrum data by the Unity engine. I began my trek by searching up Unity spectrum data to see if it was even possible to access this via Unity. I first looked at our good old friend, the Unity manual. There I found a simple explanation on accessing the spectrum data. The explanation, however, was not really clear. A lot of unknown terms were used, such as the term FFT window, which I'd never heard before. I then decided to do some research to figure out what these terms actually meant. After doing some research and visiting the Unity manual and a few online forums, I learned that FFT windows get a subset of audio samples and calculate the harmonics present in that subset. Depending on what time of harmonics you want, you should play around with the FFT window type. I also learned a lot of other valuable information, and I was finally ready to make a start on my version of an audiovisual system for No Control. I started by making an audio spectrum class that would inherit from mono behavior. In this class, I made a float array to store the audio spectrum values. I also made a general float property to store the spectrum data value for a specific sample. Then, in the update function, I added a listener to listen to the correct audio sample, and that would then get the spectrum data from that audio sample. The final step in this class was to check if my audio spectrum data array actually contained any data, and then to set my general spectrum data variable equals to the first bit of data in the array times a multiplication value. This multiplication value is arbitrary, so it can be changed or manipulated to get different results. The next step was to create a general audio syncer class. This audio syncer class would serve as the base class for all syncing behavior I was planning on making. In this class, I stored the following important variables: bias, which determines what spectrum value will sync to the beat; time step, which determines the minimal interval between each beat; time to beat, which determines how much time before the whole visualization takes from start to end; and finally, the rest smooth time, which determines how fast an object will reset to its rest state after a beat. After these variables were created, I determined the on-beat behavior. Here, I set the on-beat boolean to true, and I reset the timer to 0 that determines after how much time the object will sync to the music. Finally, in the onUpdate method, I determined when an object should actually be on beat. In this case, when the last audio value is larger than the determined bias, and when the current audio value is smaller than or equals to the determined bias, as well as when the timer has reached the time step variable in value. The final step was to increase the timer by time and delta time so that it would track the time passing. This audio syncer class is extremely useful as it can be implemented and inherited from by multiple classes to enact certain sync behavior. For example, it could be inherited by a color sync class that could change the color of an object when needed, or it could be inherited by a scalar class that would change the scale of an object on beat. There are so many useful things that you can use this base class for. To test my system, I decided to create a color sync changer component and a sync scalar component to manipulate the colors and scales of game objects on beat. I started by entering my empty scene called Music Testing Scene. The first thing I created in this scene was an empty game object called song that would store the song I wanted to test with. This game object contains an audio source component as well as the audio spectrum component that I made. The audio source is the song I want the audio spectrum data to be taken from. Then I created an empty game object called Music Bar Manager to store my musical bars that I wanted to make. I added a UI image element called Music Bar that would be the object that would change on beat. I placed this object in the left corner of the scene to test. Then I added the sync audio color component to this music bar image and I changed some of the values to test. After this was completed, I played the game and to see if it worked, and as you can see, the colors changed to the beat of the song. Once I'd completed this system, I ran a couple of tests to see what the possibilities were of implementing this, and this is what I came up with so far. And that was my implementation of the Unity audiovisual system. I hope that it was clear and that I gave you a little bit of insight to how this project works. Thanks for watching and hopefully see you next time.